minutes late. Welcome everyone to another Kent Seminar. It's actually the second before the last, and today I'm very honored to introduce two of our amazing speakers. We have Dr. Ziyadi and Dr. Kang. They both were Al students, and they left not long time ago. Dr. Ziyadi is actually the head of data science and machine learning at Lucid Motors, and he earned his PhD from UIUC in transportation engineering and his master's also in transportation engineering from Sharif University of Technology. Dr. Kang serves as the lead research scientist at Lucid Motors, and his research interests include life cycle assessment, pavement vehicle interactions, electric vehicles, optimization, similar stuff that we do here. And he also earned his master's and PhD here at UIUC in transportation engineering. We had actually a funny slide, but now, no, because we have we are already a little bit late, so maybe we can show it in the meet and greet session. I don't want to delay this talk any further. Please join me in welcoming them.
All right, yeah, we're sorry about that. We were a few minutes late. Thanks, Lama, for introduction. It's true honor and pleasure to be here after a long time. I mean, 5 years is a long time in my opinion, but really a pleasure to be back and being able to present here with Dr. Kang, Seunggu, my friend, and colleague. We have a really packed also presentation today. We'll try to make it hopefully not too long. I don't promise we'll be on time. So for some of the topics that we were going to cover today, we had to redact a lot of information just to make sure that it's publicly available, that we can talk about, and there are a few things that hopefully we can talk in details after the talk today. But feel free, if you have any questions, we can address during the call or after the meeting, whichever way you interrupt us. If you have any questions, just let us know. All right. Topics of today, quick intro about Lucid Motors technology. You probably have heard about Lucid Motors, but it's a little bit of the detail on that. Data monetization, what's the role of data? That's the title for today. And data monetization is a big topic, and how we use data in EV industry. Technology requirements to do that data monetization and utilize data and make data products. A few AI ML applications in EV and specifically in the automotive industry, specifically in EV. A quick demo and product sustainability, which Dr. Kang is going to cover. Also another data product that companies can focus on. So Lucid Motors, you probably last year, Lucid Motors won the Motor Trend Part of the Year award for the best EV in terms of technology. As you can see, one of the publications, independent publications from Insider EV, Lucid Motor Air Dream Edition, got more than 500 miles in range. As you can see, but by far the best range in the market. There are a few other technologies that Lucid stands out in terms of its basically core technologies. And the reason that we get to that range of 500 miles is not as easy as an EV. Whoever works in this space knows that it's not easy. Getting 1 mile out of your battery and the vehicle is by itself is challenging. But Lucid basically designed on a Leap platform, which is basically a skateboard concept for EVs. And there are 6 key components that make Lucid technology stand out from the rest of the EV companies out there. Battery pack and technology, battery software management, that's one area. Electric motors, that's another area. We're going to talk about a little bit about each one of these topics. Power electronics, transmission control software, and two-way, basically bidirectional charging capabilities. These are some of the key areas that Lucid stands out in terms of the rest of the companies out there. So if you want to get to a range that we talked about at 500 miles range, you really need to do 2 things in this case: increase your battery capacity or improve your efficiency. And Lucid has achieved both of them. We have the most efficient aerodynamic design in the market with drag coefficient of 0.197. And also increased battery capacity. We have the most dense battery, energy dense battery pack out there, which means that, of course, we can pack as much as battery. So battery pack is nothing just the cells as a typical cells that you see, just the commercial version of that. You pack in a specific design and platform. You can basically pack up as much battery you want, and you can get 1,000 miles. But Lucid achieved this because if you add more batteries, you're going to add more weight to your car, which means that you're not going to get that range because now you're a heavier car. So Lucid achieved it by optimizing its efficiency by using same amount of battery pack, but in a very specific design that Lucid IP for that. And we have a technology that we have built specifically how you design that cooling and heating system and all those. There are lots of details in all these technologies. So these are some of the areas that makes Lucid stand out. In terms of motor technology, so Lucid has the, let me get this one here. So drive unit efficiency. Lucid has developed one of the power dense drive units out there. Power density is defined by horsepower divided by kilogram of the weight of the motor. So as you can see, Lucid Air has a coefficient of 9 or ratio of 9 horsepower divided by its weight. Way above at least 3 times for the rest of the companies out there, some of the competitors. And basically you can see the picture there, it fits into your suitcase. It's as small as that, but it provides up to 1,200 horsepower, 1,200 horsepower, which means that there are a lot of applications outside of automotive industry, even other modes of transportation. We can think about airplanes, ships, other modes, and trains. There are lots of applications for such a motor technology that Lucid has. Usually in the EV industry, some of these technologies are basically outsourced, especially if you look at many startups out there. They usually get some of these technology from some other vendors, but Lucid owns end-to-end everything from design and R&D and building the system all the way to manufacturing and all that. And also, Lucid started in luxury space, so the quality of material and sustainable material that has been used in the finish and touch of the vehicle. I'm not sure if you've seen any Lucid motors out there, but if you're in the Chicago area, there are studios you can go and sit and feel the inside and also test drive it. I myself have driven it a lot, so it's a very nice car. It's a really, really luxury experience that you get. And also, of course, the technology provides you the horsepower that 0 to 100 is 2.9 seconds. So it's crazy fast. Now let's move on a little bit of talking about data. Now we have this Lucid as a car, and has been in this space. And around 2.5 years ago, when I joined, we started building an ecosystem of data-driven companies. So we want to make Lucid as a data-driven company. And for that, you need data. And when we talk about data, there are multiple sources of data that we can think about. But major source of the data is the telemetry data, as we call it. We collect from our vehicles. And these data is one source of data, but it's not everything that we have. We also have other sources of data, which comes from manufacturing, supply chain, sales, marketing, all of these. These are different databases that sit around. As a company, if you want to make a data-driven company, you have to make sure that you understand where the data is and how you access it and provide it and basically make that, as we call it, data democratization, so everyone has access to the data. To do that, we need to be able to properly design it. And one point here is that today's EV cars, and especially Lucid, is truly a software on wheels. And this is a new concept that in traditional automotive industry is not really following this, and they've been lacking behind. But companies like Lucid, we have taken this opportunity. There's a concept of over-the-air updates, which means that you can send software updates over the air to the car and backwards. So it's two-way communication with car, wirelessly through cellular or Wi-Fi. You're connected to the car. You can do all those things. As I mentioned, we have various sources of data, from telemetry to corporate level data. And just focus on the telemetry data, we have hundreds of sensors and ECUs within the car. And we're collecting thousands of signals basically from each car. And that's basically equivalent of billions of rows of data and the gigabytes of data basically per car per day. So you can think about how enormous this number is. It's truly a big data, and you need to have proper infrastructure that you can support and get to use this. In our team in data science and machine learning, once we have this infrastructure set up, now we're focusing on providing ML solutions. We provide ML solutions by using advanced analytics, AI, and machine learning that can span from predictive analytics to event detection, anomaly detection, R&D, helping with a lot of other teams and departments within the company, optimizations, digital twins, a lot of these topics that come into basically in our realm that we can help company grow. Now let's talk about data monetization. Data monetization here in this case does not necessarily mean that we want to sell data to make money. So there is a framework called the IWS, or Improving Wrapping and Selling Framework. This framework was introduced back in 2018 by Dr. Andreas Wiegand from Stanford University. And it's been right now taught in MIT Sloan School of Management, actually, as part of their data program. And it's not a new concept. It's just a framework that we add, Dr. Wiegand added to this the whole spectrum of what is it. So improving is basically process change. What does it mean? Once we collect data, you need this data to be available to everyone in an organization to be able to use that data. Enabling that organization requires a process change. That's called improving. That's one pillars of IWS framework. So you need to provide access to data and basically change nature of work. And we have this example in our company where engineers, they're working on say on a motor or battery pack. Once we have these signals and collecting these billions of rows of data every day, we need to provide it back to them so they can look at this data. That's one part of data monetization, which means that you are not just collecting data and dumping it to the database. You need to provide it back to the system and to the organization to be able to help them. That's part of improving called in this system. The other one is wrapping. Now we have the data. What we can do, we can go further and use this data to actually build some products that our engineers or end customers, they can use this as in their processes and get better. So which means that in this case, we are basically such as reports. You can generate an analytics report and give it to the engineers. Look at this. This is how your battery pack is performing over the time, and they will get insights from data. So you do that analysis for them. You provide that insights. It can be a simple alerts, simple visualizations, all the way to intelligent products and solutions, machine learning-based applications. So that's the wrapping part. So you are building, using data to build additional insights from data and provide that back to your internal teams or external end customers. Either way, that's called wrapping. And of course, IWS framework includes also selling, which means that now I have this data. What else I can do with that? Simply, let's sell it. And that's brings another concept of how you sell it. You can sell it as a raw data. You probably, when you Google, right, it says that you give me a consent that I can share your data with other third-party companies. That's part of that selling model. That's the raw data. The other part is insights. You can, instead of selling the data, which most of the time involves PII, personally identifiable information, or privacy concerns. I cannot sell our customer data directly to our someone else. You can instead create insights and use that insights to basically make money for a company or organization. That's on the insight side. Or less applicable in automotive industries actions, where you actually do consultation using the data for external vendors. You can do additional consultation using the insights and data. It's less applicable in our industry. One thing in insights, like in a good example of selling data indirectly is, say we are working with a vendor that provides a small piece of, say, battery actuator, whatever, contactor for us. Over time, we have sensors. We can monitor performance of that sensor or that piece of equipment, in this case, actuator in the car. But that provider, the vendor that provided that piece of equipment for us, they don't have access to the data, right? That's our data. We're collecting data from our fleet. What we can do, we can build these insights, look at the performance of those sensors, those actuators, and over time, we can build more insights from that and how they perform, build a lot of prediction models, but that insight can be sold back to the vendor. You can get more discount because I'm providing back to you. You can make improvements on your product. In return, I'm going to benefit from that too. So that's a partnership model that sometimes you need to think about. You can build with these types of basically vendors. So all of these concepts that I'm covering here, as you can notice, it's more towards business concepts and a little bit on outside of research domain. And there's a reason that I want to give you a new perspective of how your knowledge and you're taking courses and all that, how it can come in handy when you go to any domain, academia or industry. Same applies. How do we measure the outcome of this data monetization? Basically, you can simply just calculate the direct revenue, right? You can see how much sales lift you had due to this new solution, or you can look at the indirect revenues from customer satisfaction or loyalty. That's another way you can basically look at monetize and measure that, or direct or indirect cost and time saving. This is very important. when you have data and you provide that back to your organization, you're saving them time by letting them have quick access to data. If they wanted to do it themselves, they have to go, for example, to the car, pull a USB drive, and then get the data, come back to there, and then look at the data. But instead, you're providing that functionality. That's very time saving that comes in. So how do we build this IWS framework in an actual industry and an actual corporate business? It really requires a few things: analytics, data science, AI, and ML knowledge to get as sophisticated as you can, and also technological capabilities. Now, we know about the green part here: analytics, data science, AI, ML. You take courses, we learn all this in classes. That's all good. That's necessary that we do it. I myself have done it. So a lot of theoretical knowledge that we learned. But when it comes to corporate and business setting, you need to put them in practice. You need to bring them to the reality. It's beyond the research topic. And especially when you go to also academia, that also becomes another topic that sometimes you need to think about, okay, what's the outcome other than publication? You need to build something that someone, IDOT, DOT, FHW, they can use it. So the concept of making a data-driven product becomes another topic, which requires some technological capabilities. What do we need to have that? So what are the technology requirements? First and foremost, all the things that I said are good, but you need to have a very good infrastructure for that. It can be cloud infrastructure, or it can be on-prem servers that sit somewhere in your organization. Either way, you need to have this. It also comes with we have concepts of development, staging, and production environments. These should be defined. You know that when you're developing in one environment, in one infrastructure, you're developing your algorithm, where you're developing your solution. When you want to move it to production, where that is, the differentiation between these, all of that should be defined. Of course, data pipelines, where data comes in, from cars to the backend. You need to have a proper pipeline, storage, database management. These are very important topics: ETL, extract, transform, load. So in the past few years, we've been working on these frameworks and bringing these to life in Lucid. And in 2 years, we have made a lot of progress in this space on all of these topics that we're mentioning today. Big data technology. Of course, when you have billions of rows of data, how are we going to process data? Even a simple query, give me a certain data for speed from this day in this car. You cannot do that as simple as I mentioned it. MATLAB is not going to run that. Nothing can be that. So you need big data technologies. And I'm not going into the naming any tools for these. There are different various options: open source, paid, managed services. So, but these are the core technology. I'm talking about the technology requirements. I'm not talking about tools. Someone might say that, oh, we have Spark as an open source tool. You can do for a big data. Yeah, that's one option. Development and orchestration tools. So as a scientist, I want to develop, but eventually I want to see that in action. Where do I develop that? Orchestration tool. I have an application that I want to run it every day, every minute, whatever, right? Does a monitoring of my, I don't know, oil pump to see how it's performing. It's all happening in the backend, not in the car. So you need to have proper, basically, orchestration tools in this case that application can run on a continuous basis. And to be able to do that, you need compute resources. If it's a heavy algorithm, it requires GPU. You need to provide that, it's CPU, all of those details. And of course, if you're doing more sophisticated machine learning, you need ML lifecycle management tools. Where do you build a model? How do you push it? The training of the model, how do you push it to production, monitoring in the production? How does that model registry should look like? Serving of the model. If you're serving, say you have hundred thousands of vehicles out there, how do you want this model, that ML model, that to be performing on that 100? How does that scale? All of these are questions that falls under to that category that we need to find a solution and solve it. And business intelligence capability, which means that once you have all these settings, you need to present it. You need to show it. You need to give it to engineers, to customers, to see it, to take action, to help them. That comes business intelligence capabilities. So this is an ecosystem mainly focused around the backend cloud-based ecosystem. But at the same time, it also applies to when you are building applications that runs in the car, inside the car. So you can push your algorithm. For example, you have an ML application you have built for object detection, but you need it to run in the car. It has a similar pipeline. Concepts are the same, but however, different toolings that you need. And in this case, you need an edge compute where you can deploy your model to. A lot of these also touches on the software capabilities. So when it comes to reality of the business, you need to have all different skills, and one person wouldn't be able to master all of them. So it's a teamwork. So you will have a lot of teams working on different domains and different aspects. Before we go here, any questions so far? We're doing good, following, all right, good. Again, I cannot go to some confidential, information or some of the things that I cannot talk about. I wish I could, but bear with me. This is the level I can go as much as I can go. So, all right, let's look at some of the applications. We talked about predictive analytics, applications of AI. So predictive maintenance is one of the simplest applications you can think about. How we can predict if my oil pump is gonna, be gone at some point and then damaged and not going to work. How we can do so? That's a predictive capability that we can bring by doing some predictions and using data to build these models. Fleet health monitoring, similarly, monitor the whole fleet for different basically events, as we call them. Battery modeling, a lot of applications of AI ML in battery modeling, battery state of health modeling, SOH it's called, state of charge, time to charge prediction. For example, when you charge a battery, how long is it going to take to charge from 2% to 100%? Prediction of that, it's a very sophisticated actually problem. There are battery models, there are physics-driven models, but also role of data, maybe it's a good segue to talk about this part, that we are engineers, we have worked in this space as civil engineering and mechanical or battery modelers. As much as we like to work on formulas and analytical solutions that are derived from lab tests, you do binder testing, you develop some using some fundamental physics, you derive some equations. But as more and more we collect data, you guys are doing it today, you're collecting data. And just look at us, we're collecting billions of data every day, right? As you more and more collect data, in my opinion, at some point, these engineering problems, because it's not fundamental physics, right? It's not nuclear physics that they're fundamental. They involve a lot of factors. And when you build a road and pavement, there is environment, in fact, there is how users are using it. There's a lot of basically influential factors that goes into that system. It can be a building, it can be any infrastructure. In my opinion, sensors are cheap these days, and a lot of data we're collecting. We're going to move away from mechanistics design towards data-driven design. And it's showing its capabilities. It's a matter of time. More data you collect, you need to master these capabilities. You need to know how to use data. And I think it's a requirement, in my opinion, is a requirement for any undergrad and graduate school students to take courses in this area, is how to use data, especially big data, machine learning, all these concepts we need to learn, because that's the future where we are heading. So it's, in my opinion, someone may disagree with that, but that's my prediction for the future, is that all of these designs, engineering designs, are going to be data-driven designs. Anyways, moving on. Cybersecurity. These are some of the topics actually we're working right now in Lucid. So cybersecurity also has some applications, intelligent threat detection. You can think about it. There's a lot of AI application in this domain. Very hot topic. How do you detect if someone is just I'll give you a simple example. For example, if you have a lock-on-lock door, right? You get to the car, it's off, and then you can do it. There is a limit for human capability to do lock-on-lock per second, right? It's 40 times per second. As simple as that. It can be as simple as detecting if I see that signal, lock-on-lock, is happening more than 40 times per second. It's outside of human capability. There's something going on. You can detect it. You can alert it. Say, oh, something's going on. Flag it. It can be as simple. By the way, that's not as simple as I said. So what is that 40? Is that 40, 50? So this is where all these statistical machine learning data and all those techniques and skills that we learn come into the picture. So if you ask an engineer, yeah, let's put 45 clicks per second, right? Who says 45? Why not 50, right? So we come from a domain that we can look at the data, and instead of saying that, for example, 45 times per second, let's look at the distribution of the difference of the time difference between each click, and create a distribution over that, and define a 95 percentile threshold where it defines my 95% confidence, where I set that threshold there, saying that I have 95% confidence, where if you exceed this specific number, that's I'm telling you that that's maybe a threat. So there is statistical ways that you can justify things. You can prove things that this is how we approach. This is the scientific mind that goes into these problems. ADAS and AD, I think the famous one, autonomous advanced driving assistance systems and autonomous driving. At Lucid, our focus is not in this part. This is an R&D in the company. But of course, AI ML has the biggest application. But in my opinion, when I joined Lucid, I found out other opportunities more compelling and more basically bringing more value for our end customers in short term. That's why we've been focusing more on the other sides. This is also, of course, active in the company. Digital twin is another concept. It has a lot of applications, many different domains and areas. If you can ask many people, they will have different opinions about it. But in our case, digital twin in this case means that engineers, when they build control algorithm, for example, for battery, we talked about. So there is a battery ECU. There is a model inside that battery ECU that tells you as a physics-driven, whatever that's the battery engineers they design. It says that if you plug in, it's going to take you half an hour to charge from 2% to 100%. That control algorithm, how you design it, how you integrate it, all of these takes time, which means that an engineer needs to design that. Then they have a test bench. You have to push that to the test bench, run it there for multiple times, see it's performing the way that you expect it, then push it on a test fleet, run it on 2-3 cars, monitor it for a few days and a few weeks. And then for the next rollout, you can roll that algorithm out to the car. So now I have a final product. What digital twin here is, let's just cut that all. Let's recreate a digital version of the same ecosystem, the battery component that's happening in the cloud, and let engineers use that as their benchmark. That's exactly as expected to perform as if you're running in the car. Not only that, you can run it at scale for thousands of cars at the same time. And also you can connect it to the historical data, not only to run it for the future, but also you can run it for the past events and test. So this is an accelerated testing. There's a lot of benefits there. That's another active project that they've been working on. Another hot topic these days, natural language processing. It's believe it or not, has a lot of applications actually in the automotive industry as well. It may not look like natural language processing, NLP. What is it to do with a car? It's a mechanical, system, whereas this is a language. I'll show you an example. And many more. There's lots of applications. Just think about it. There's a lot of applications for data, AI, analytics, machine learning. All right, let's do a demo. I spoke about NLP and natural language processing. You have heard about ChatGPT probably. Unfortunately, I cannot show you the actual example of ChatGPT that we built at Lucid, but I have the design. This is very quick. I think all of you can do it in a few days. GradGPT, and let's give it a try. So what does GradGPT does? This is our GradGPT. So what I did, there is a website, I have it open, grad reports. There are a lot of comments from mainly students. They talk about grad school at UIUC and how it is. They, as you can see, they scored some of the programs. And there are lots of comments, actually around 220 plus comments in different pages and all that. So what we did here, I just quickly escaped through this website and collected all these comments. And with this GradGPT, what we can do based on those contexts, which is in this case, the 200 plus comments from students, we can ask questions about UIUC program. And it will answer us based on the context that I provided to it. So in this case, we can test it out. So I have a few examples. And I'll let you ask also questions. So let's see, how is the faculty at the University of Illinois? Based on, this is also answers based to this, based on the comments from students. All right. The faculty at U of I are warm, accessible, and reasonable. Oh, okay, nice. They are passionate about teaching and are available for students through mandatory office hour time. That's nice. They are also receptive of students voicing their opinion and asking questions. All right, that's good. Seems like people are happy about it. Speaking of that, now let's look at some of the improvement areas for faculty. All right, I think this one is interesting, right? Again, answers are based on the context, student that they thought about it. All right. In this case, some improvement areas for faculty at U of I may include providing more training time for teaching, hiring more faculty to strengthen programs, and providing more financial assistance. All right. A note for faculty members to pay. Let's see what else we can ask it. Well, we can ask all of this, but anyone wants to ask any question, we can ask it. Like say, what are some of the most complaints about CE department? How about that? Let's see. Maybe they're gonna call out Professor Tudumar, you're here. Maybe they're gonna call out your name.
I'll send it to the department.
Let's see. All right. Some student complaints about CE department include poor development.
Okay, I walked.
All right. Skip that. Lack of no, that's not good. Okay, limited for a few classes. A few classes per semester. That's a good point. We may include that for next time. So as you can see, I'm showing you an example of how new technologies these days you hear about it and how much application it can have. And this is specific technology, ChatGPT. I mean, ChatGPT, I don't want to go to the details. It's specifically designed by OpenAI, but it's a GPT or these are transformer language models. I don't want to go to the details. But the whole point being is these technology, you can use it in many different ways. Just think about it. One of the applications that this is going to have is data analysis itself. You can give it data and ask questions. You don't have to plot anything anymore. You can say that, okay, given this data, tell me what characteristics of binder this has. Ask any question that you have, as long as it has a context, has a data, and you provide the context. Context in this case is papers published, any hand notes that you know about this knowledge, what is binder, all of that. That's basically what I did here. I dumped all that student comments. It's, I think, 1 page, 200 plus comments. It's like a couple pages. You dump it, it learns from that the context. So in this case, you can add your own, papers, books. There's no limit. You can add anything you want. That's the context that you're providing. Then you can ask questions about within that context. It will provide you answer. Lots of applications in automotive industry. The way that we're intending to use this is for our complaints from customers, where they see the problems, and for service center, if they have seen this problem before, where was that, how was it fixed? All of this, some of these are not query based. You can query a database, say that, okay, when this problem happened and how it happened. But you need to have a database for that beforehand. You need to prepare it in a, relational database. It's columns like Excel, so you can query it. But in this case, you don't have to do any of that, because that's a manual work. Someone needs to design in a specific way, and you're limited to the boundary of that table, that concept. You cannot go outside of it. So there are lots of applications on this. Just wanted to show you one cool project. All right. Next, I think we have Seunggu. I think we are on time a little bit. All right.
Can I?
Oh, yeah.
Well, thanks, Dr. Ziyadi, for a very, very comprehensive overview of what Lucid is doing in the area of machine learning and AI. This is actually one of the recent projects that data science team launched. So product sustainability is another area that we recently started working on. Will you next? Oh yeah, sure. Escape. Yeah. Okay. All right, sorry about that. So the product sustainability really considers all different stages of life of the product that you are considering. For example, here, the product system that you're considering is going to be EV, and EV has certain systems that you need to consider, stages that you need to consider in goal and scope. And after you define your goal and scope, you're setting up your sustainable strategies to maybe reduce your carbon footprint or other economic impacts. And through these sustainable strategies, you can actually collect the data and build your databases to further and analyze your data and quantify the environmental impacts. And with this impacts, you can actually use it for different applications. For example, the top right is actually showing you the map of decarbonization of the company. And the middle is actually showing you the certification and the compliance of the results that you got from your product sustainability analysis. And also the last is the optimization process. So from here, I just wanted to actually talk about life cycle assessments, what life cycle assessment is. Does anyone here heard of life cycle assessment before? Can you raise your hand? Okay, majority of you guys, but to be for those of you who actually haven't heard of life cycle assessment, this is actually it's actually the most widely adopted sustainability measurement methods across the globe. So when you consider product system like the EV, for example, then everything actually starts with the raw material extraction, manufacturing, distribution, use and disposal, and it goes back to the system to the manufacturing of the materials again. So if you consider this product system as an EV, then certain inputs are going into this systems. For example, the materials or resources, electricity, fossil fuels, as well as water. And as an output of this product system, you're of course going to get the final product, as well as some of the emissions to the water, emissions to the soil, emissions, as well as the waste. So life cycle assessment is really defined as a data-driven methodology to quantify environmental impact during the product life cycle. So if you actually look at this graph, you can actually see automotive industry is actually heading to the decarbonization, and each of these companies, they have their own decarbonization roadmap. And this is actually showing you how the carbon footprint is going to be, how each of the companies are planning to reduce their carbon footprints with the time. So for example, if you look at this light blue line, this is actually the line that shows the carbon predictions of Rivian. And this is Rivian's plan to be carbon neutral by the year of 2032. So this is like in 9 years, Rivian is actually committing themselves to reach their carbon neutral stage. But some other companies have a longer roadmap. For example, the Toyota, for example, this orange line, this is actually showing you they're actually going to the net zero commitment by year of 2050. So depending on which company, they have different carbon roadmaps because they have different conditions and resources to decarbonize their company and operation. And another area that we want to focus on in the product sustainability is looking into compliance. And if you note, the European unions are very strict about the carbon emissions and material use. And one of the recent compliance requirements that every company has to meet is actually meeting the declaration of carbon footprint that is verified by the third-party reviewers. And this is actually should be submitted with the product. And otherwise, there might be some kind of a penalties associated with not meeting the requirements. And another compliance that is coming is battery passport. So battery passport is something that's tracking all the resources, raw materials that is going into the AV. We're tracking actually down into the supply chain and then make sure where the materials are coming from and where it is processed. So all these information will be actually digitized and then contained in the QR code related fashion, and then it will be available to the organizations to review. And also the last is the battery threshold. So after you pass these two deadlines, there are certain kind of thresholds, maximum threshold for the carbon footprint. So if you are over the threshold of carbon footprint, then there might be some penalties that is associated with the batteries that you're selling in the European market. So those are compliance issues that product sustainability can provide some service to resolve these issues. And also one thing that we can consider is at the impact of use stage, because use stage is usually considered as the largest source of carbon emissions. And since the EVs are actually powered by electricity grid, so you're getting actually energy from the electricity grid to power EVs. So how clean the electricity is going to be determining the quantity or the magnitude of your use stage. So that's why it's very important to consider the spatial and the temporal variations of your electricity grid, because if you have a zero carbon electricity grid, that means you're not going to have any emissions for your EV operation. So spatial variation is actually showing us what kind of emissions or what kind of resource mixes we are going to have for different regions. And it's not just about the spatial, again, this is about the temporal variation as well. So this is actually showing us what the projection of the resource mixes for the Illinois, for example, is going to be through the year 2022 to the year 50. And we can see that the carbon footprint associated with the generation of electricity at Illinois is actually reducing with the time as you change the resource mixes from 2022 to 2050. So these are some discussion about the temporal and spatial variations. And one last thing about product sustainability is about the end-of-life management of battery materials. So battery material is really scarce. We don't have we have a limited amount of materials for battery production. And we are expecting that the number of EVs are going to be increasing a lot with the time. So that actually means there is a need for recycle the lithium-ion battery, which is going to be installed in the EVs. And when the lithium-ion battery reaches end of life, there are some materials that are going to be critical for rebuilding the batteries. So some of these critical materials include lithium, cobalt, manganese, as well as lithium, or manganese and cobalt. So lithium, actually nickel here, cobalt here, and manganese here, and this is lithium. So these are four critical materials that you can recover from the batteries that reached end of life. So these are some of the concerns that product sustainability can reserve in the company and in the industry, automotive industry. So with that, I have a concluding remarks. Please feel free to chime in, Dr. Ziyadi, but the EV range is highly dependent on the battery capacity and powertrain efficiency. And also Dr. Ziyadi mentioned that data monetization, the process change, product change, and data products can result in the generation of direct and indirect revenue, as well as the reduction of the cost over time. And also achieving these goals require properly defined and designed technology stack. And AI ML application on EV includes, but not limited to, predictive analytics, cybersecurity, ADAS, digital twins, as well as natural language processing applications. And also the product sustainability is contributing to establishing the decarbonization roadmap for the company as well as the automotive industry. So with that, we actually conclude our presentation.
Yeah, we have a few minutes if we have some questions in the room. Yes, welcome. Go.
Thank you both for the nice presentation. I think my question can be directed to Seunggu a little bit more. So we know the three pillars of sustainability, which are like economic sustainability, environmental sustainability, and so on. In your department, in your research, you focus on the environmental sustainability as maybe the financial sustainability is responsibility of someone else. How about social sustainability, especially with controversy that sometimes, pops up about the batteries, how they are, the materials are extracted and so on. Did you consider doing any work on social system?
Yeah, that's a very good question. So if I understand correctly, so it's about the how do we take care of the social aspect of EV product. So we are actually the question is really good. We're not directly working on social aspect of the products because we are more like quantifying the environmental impact as well as economic impact. But the social aspect of the EV production is actually taken care of by have you heard of ESG, environmental social governance? So this is another department or team in the Lucid, and then they're actually working on the social aspect of the getting like raw materials from the sensitive location and so on, like child labor and stuff. So those are actually being investigated by ESG, and then this is actually there is some kind of regulations about the social aspects as well. So we are actually working with ESG team very closely, and then so social is another very important portion that we can actually help with the ESG team. Yeah, if that answers your question.
We have a question on Zoom from Egamin. Egamin, can you unmute?
Hello, nice to see you, Ziyadi and Seunggu. Very nice presentation. I have a quick question. So last month here in the New England area, our electricity rate was around 46 cents per kilowatt hour. And there are some ongoing concerns about this shift to the grid, making this higher and higher, and maybe at some point even making this not even a financially sustainable mode of transportation. So do you guys have any ideas on that, or how we can approach that in general in the US?
Right. So so this is a really complex problem, and actually there should be a lot of involvements from the federal level government as well as a state level government, and also collaboration between the two. And I know how expensive the electricity is in New England. I live there. So it's really problematic, and but I think one-time investment or more investment to make the electricity green is going to make electricity more expensive. However, by making this electricity green, we are actually getting a lot of different benefits from there. For example, we can actually, promote, sustainability to the public, and also we can. So this is actually it gets really complicated because, as you know, carbon increases, and you're going to see more extreme events happening throughout the world. So if that happens, there is a lot of economic consequences, and then that's making the grid clean is actually one of the ways to make it less frequent than before. So it's a complex topic. If you want to chime in, Max. All right.
Can we take one last question?
Pleasure to see you both, and really exciting what you are working on now. Seunggu, you showed a plot of the different goals with the different entities, Stellantis, Toyota. Where does Lucid fall into that? And also, so it was nicely categorized with even the framework that Mustafa earlier when he put that graph of where the data are coming, the different algorithms that are used. How does Lucid integrate that category with sustainability, where some of your solutions are driven by sustainability metrics as well, not just optimization and efficiency?
Right. So the question was about how sustainability integrates with the framework that I mentioned, and also you had the one before that.
You showed like the different
Oh, yeah,
goals,
yeah.
right?
Lucid
The
stats.
carbon
So,
neutrality and
yes.
net zero, where does Lucid
So-
land into that time
Yeah,
frame?
let me understand first. So the plot that Seunggu showed about the carbon net zero goals, those are publicly available information. So if you don't see Lucid there, that means that it's not publicly available.
Okay,
So that answers that.
sure.
Okay.
I mean,
Then your second question about, sorry about that. For how we integrate. So one of the works that we're doing, it's exactly what you mentioned, which is outcome of our sustainability studies, where we are in terms of our emissions. One of our main goals is how that basically derives our design decisions. And right now we're working with engineering and design teams to focus on top, say, 3-4 contributor factors, for example, material, where we can change the design accordingly, so we can optimize our emissions. So that exactly comes to the place that you need that cloud infrastructure to do that. In this case, where the data is, how you access this data, how you process that data. So you can see the sustainability as part of our wrapping framework. There was improving, wrapping, and selling. So this exactly fits into the wrapping framework, where we access data, we process it, we return the results back to the company, where engineers and designers, they can sit down and look at the result. We provide these tools for them. They can play with, say, just hypothetically, if I change metal to aluminum, what's the impact on my environmental impact, right? And then where you can optimize that design, steel to aluminum. You know better than me on that, but so that's the whole ecosystem, right? So if you think about it, it's a intertwined, complex system that all should work together until you have that full cycle of data to decision making.
Yeah, thank you. I think Professor Alcari wants to say a word. He's been traveling and he probably wants to say something. You on mute.
Yeah, I'm sorry, I was stuck on traffic and I couldn't be there. But I'm so glad that Seunggu and Mustafa could join us today. I will see them later today, of course. And I just wanted to share that these two gentlemen are very, very exceptional. And I guess you could tell from the presentation today, and I'm so glad that they could be here today. I should mention something unique about each one of them. I'm always was impressed by Seunggu's organization, and I never knew how he was able to do that. And Mustafa is the one who brought the idea of out of the box to the group. So the presentation that we do out of the box, it was because of him always coming up with these ideas that he wants to discuss. So we're all proud of you, and we're very happy that you are with us today. And I will see you later today. So thank you so much, and I apologize again.
Thank you, Professor. Looking forward to seeing you later today. Thanks for the nice work.
For everyone, we have a students meet and greet session right after this presentation. Let's thank them one last time.